Hello, everyone, and welcome. My name is Thomas Johnson. I'm with AWC, and we're going to start today with our workshop, Cybersecurity Defense in Depth. Your instructors today will be myself, Bob Stevens, Tom DeFreitas, and Keith Thompson, all applications engineers for Florida for AWC. Welcome. We are just to take a moment to talk about safety. I want to make sure everybody's aware we partner with a company, Premier Automation, that has created what they call their Hydro Cleaner. This is a device that atomizes any solution that you would like. They suggest a mixture of hydrogen peroxide, so a diluted concentration there, and it comes with a nozzle, and you can spray it. It's the same technology that emergency rooms utilize to disinfect their rooms, but it is, if you are concerned about your employees or your customers, and also making sure that that you protect from the coronavirus and other things, this is a very cost-effective solution, and something that you can utilize not only on seats, but also electronics, as you see here. So do want to take that safety moment. If you're interested in that, please give us an email or just chat with us, and we can let you know more information about that. Also, in the event that we are Zoom bombed, what we'll do is we will shut down this presentation, and we will we'll reschedule at a later time. But some of the things that we have, just some housekeeping notes. We've muted everybody, so just for everyone's convenience. We also ask that you not share video, just to help with bandwidth for everyone. If you do, you might see that you've shared video and that we stopped it. That's just to help share to save bandwidth. And also we have, because we've muted everybody, we have the ability to do chat. So in the bottom you should see a chat icon. You can chat and ask anyone to attend, or excuse me, anybody to answer a question, and we have engineers ready to answer. We'll also be recording this webinar. So if you do have a question that didn't get answered, or if you want to recheck something later on, we have that ability. We'll send out that link to everyone here as soon as it becomes available. So today's workshop is about cybersecurity. To help illustrate this point, we're going to use an example that we have a plant that has a company network, and we've ordered a new machine. It's going to come with a different IP address structure, and we may get more machines like this in the future. That's kind of where we are. Now, where do we want to go? We want to be able to hook up that machine to the company network so that we can check the status. It does have Ethernet capability, operate it if we need to, and be able to change the program as well from a programming PC or PG that we have on the company network. So that's where we want to go, but we also have been told to make it secure. So we want to prevent somebody, unauthorized from being able to do that. So how are we going to get there? Well, we have several different things that we are going to do. We're going to install a security device. So this is the Siemens S615. And we are going to then set up Masquerading. And we're also going to set up network address translation. And then we're going to set up a firewall as well. So at the end of that, what that's going to do is that's going to give our company network, and we want to keep the internal IP addresses the same as well. So to tell us more about these and to go over some of the basic concepts of cybersecurity, I'm going to pass it off now to Keith Thompson. He is our South Florida AE. And like I said, he'll review some of the basics of cybersecurity and then review the concepts of masquerading, network address translation, and firewall. So Keith, can I pass it off to you?
Yes, Thomas, thank you.
We can hear you.
Let's see, and can you see my main trends?
Yes, we see your screen.
All right. Thanks, everybody. We're we want to take a look at the main trends impacting the vulnerability of our automation plants. Of course, we've had increasing amounts of horizontal and vertical integration in our networks at all levels, and the connection of automation networks with IT networks and the internet for remote maintenance. We have increased use of open standards and PC-based systems. And all of this has created possible threats for exploiting our networks. An intruder's objectives are to access our secure networks, escalate privileges to the admin level, and then hide tracks by deleting logs that may show new code installed or login information. They then install software allowing them to explore, identify, and exploit any resources on our network. And how do they do that? Any network connected to the internet is detectable by others. Once an IP address is verified active, the operating system is identified, and then other applications running, such as web servers, are detected. They find the known vulnerabilities for the identified operating system and applications and use those as starting points to launch exploits. When a successful exploit is found, that's when the problems begin. Some examples of such exploitation are some of you may remember the Northeast blackout of 2003, where 55 million people went without power. This was malware designed to send a message to Microsoft, and it unexpectedly attacked Unix servers, creating that blackout. Other examples are the U.S. government set up a number of honeypot water plants, and those were decoy water plants that were set up to appear as actual operational water plants, and they wanted to see what kind of attention those would gather. They had 74 intentional attacks, 10 of those which were where they completely owned the control systems when they took it over. The FBI has acknowledged an industrial control system was hacked in New Jersey in January 2012, and U.S. water treatment systems was hacked in South Houston in November of 2011. So these are just a few examples. There are probably many examples that go unreported, some examples that may go undetected. So let's talk about industrial security, the defense in depth concept. And there's three major areas of defending our industrial automation networks, we have plant security, and this is physical protection, blocking access from unauthorized persons, physical prevention of access to critical components. We also have system integrity, and this is where you have antivirus and whitelisting software. You maintain and update processes in your plant, user authentication for plant or machine operators, and integrated access protection mechanisms in automation components. But the part that we want to concentrate on today is network security, which is like the third part of this defense in depth. And these are controlled interfaces that we need to install between the office and plant network, for example, through firewalls. Also providing further segmentation of plant network for better manageability. One of the devices that we can use to do that is the Siemens S615, which is an industrial VPN appliance. It offers benefits such as cell protection via firewall. It allows administration of up to 20 VPN connections, and it provides for network address translation for communicating with serial machines with identical IP addresses. And also it allows for secured remote access via SINEMA Remote Connect. So those are just a few of the features. The Siemens S615 is just one of the products that Siemens has for providing industrial security protection. We also have versions that are in the form factor of our S7 1200 and S7 1500 CPUs, as well as other appliances that look similar to this one, but have varying amounts of capabilities. So let's look at IP addressing and subnetting, because this is important to understand for some of our security concepts. What is the purpose of a subnet? It's to segment the host within a network. Without subnets, our network has a flat topology and relies on MAC addresses to deliver packets. Subnetting lets us segment the network into manageable pieces. Because it's based on layer 3, which is the network layer, where IP addresses operate, we can apply security policies. The subnet mask tells us vital information such as the network address, the broadcast address, and the available host addresses within that subnet. Here's an example of a standard Class C network, and this one is not subnetted. So it's your standard Class C, that's identified by the fact that the subnet mask is 255.255.255.0. And this is how you would express that in decimal form. This is the binary representation of that subnet mask. And then a third way that you will sometimes see the subnet mask represented is with the prefix length. And that's this /24 at the end of a host address. And this /24 indicates that there are 24 consecutive ones in the subnet mask. So in this particular Class C network, we have a network address that's at 192.168.52.0. And that's based on this host address that they identified of 192.168.52.7. So that tells us with this subnet mask that our network address is here. And with that subnet mask, the number of available host addresses can be identified. And you can actually do that with the subnet mask. If you take 2 to the power of the number of zeros that you have here, you will get the number of addresses available. So 2 to the power of 8, we have 8 consecutive zeros here. That's 256. So we subtract 2 because we're going to use one of those addresses for the network address and one of those addresses for the broadcast address. And that leaves us with 254 available host addresses, beginning at 192.168.52.1 and going all the way up to .254. So again, this is all for a standard Class C network address network that is not subnetted. Now we're going to subnet that network. And the way we do that is we borrow one of the bits from the zeros at the end of the subnet mask. And when we bring that over and make this a 1 here, that changes our subnet mask to 255.255.255.128. which is what you get with this one on the last octet. So now in prefix length, we show that as /25 because we now have 25 consecutive ones in our subnet mask. When we do that, it basically divides that Class C network in two. And the first network that is identified is the one that starts at 192.168.52.0. And again, remember, this was the host address that was identified. With a subnet mask of our 255.255.255.128, and knowing that this is 7 zeros here at the end, we can take 2 to the 7th power and we get 128. We subtract 2, and that tells us we have 126 available host addresses. And that first host address is at 192.168.52.1. The last host is at .126, and our broadcast address is at .127. The second network that's created from this subnetting, or the second subnet, I should say, begins immediately after this broadcast address. So the network address for the second subnet is 192.168.52.128. And again, with that same subnet mask, and our first host address is identified as .129. Our last host is .254, and the broadcast address is at .255. So it's just kind of an example. By doing this subnetting, we have essentially divided the network into two, where since devices can only communicate with others on the same subnet, we've basically have a number of devices that can be on this network that can communicate together, and devices on this subnet that can communicate together as well. All right, so a quick review. Each time a bit is borrowed, the number of subnet addresses increases, and the number of host addresses that are available per subnet decreases. So when we borrow bits, we're basically ignoring the boundaries of our traditional classful networks. And just as a review, a Class A network is 255.0.0.0, and this is the representation for a Class B and a Class C network. And then there's some math that you can do. Knowing the subnet mask, you can identify the number of subnets and the number of host addresses available per each subnet. Okay, let's talk briefly about masquerading. So here's an example that's familiar to most of us, and that is the router that you have at your home. The router that you have at your home is, you get an IP address, and this is a public address from your internet service provider, and that's your external or private address. The internet router also operates as a DHCP server, and so it will also have an internal or private address that's typically it's 192.168.1.1. You can change that, but this address is the one that when you connect any of your devices to your home router, they will be assigned IP addresses that are in the same subnet as this internal IP address. So the advantage is that none of the hosts on the supported network behind the masquerade router are ever directly seen. They're relatively protected from attacks from the outside. Unwanted traffic from the outside, such as multicasting or broadcasting, is reduced. And so you have a degree of protection that's there. Now, when we look at our, our industrial security appliance device, it's essentially the same. The only difference is the external IP address is assigned by engineering or IT, and the internal IP address is typically fixed instead of being assigned by a DHCP server. In the lab that we will be presenting, we will enable masquerading for the VLAN 2, which is our external network. And when enabled, each outgoing data packet sent via that interface will have its source IP address replaced by the external IP address of the device. Again, so all the devices appear to the external side to be coming from that same external IP address. All right, network address translation. There are several different types of network address translation: static, dynamic, port address translation. Masquerading is a type of port address translation, as well as the one that we'll be looking at in addition to masquerading is destination network address translation. The security benefits of doing NATing or network address translating is that it hides the actual IP address of your devices, and there's no direct communication with the inside devices. The example that we'll be looking at in our lab looks a little bit like this. This is an example where an OEM creates duplicate machines and reuses the same subnet and IP addresses over and over again. As you can see, we have two S615s here, and each one is connected to a PLC's CPU on the S615's VLAN 1 or internal VLAN. The two CPUs have identical IP addresses at 192.168.1.10, and they're on a Class B network, or excuse me, yeah, a Class C network, sorry. And then the second CPU is at that exact same IP address. The IPs of the S615s on the VLAN 2 side, which is the external side of the S615, are at 172.16.1.1/16, and the second one is at 172.16.2.1/16. This is a Class B network. We could have done this with a Class C network, but for our purposes, we just went ahead and used a Class B network here. And you can see that those IP addresses are on the same subnet as the PC that we're going to use to try and access our CPUs. It has an address of 172.16.10.100. And again, it is on this is a Class B subnet mask, Class B network. Now, when we do this, we'll have to assign additional IP addresses to the external side of the two S615s. 172.16.1.10 for the one on the left, and the one on the right will be 172.16.2.10. So once we set this up inside of the S615, the configuration has a feature called NETMAPPing, which will allow us to identify a destination type network address translation. And this is going to take the source interface, which is VLAN 2, our external side, and the destination interface is going to be VLAN 1, which is our internal side of the S615. The source IP subnet is 172.16.10.100/32. Now, when you use the /32 for your subnet mask, that basically says that it's this IP address and this one alone. So it's a single IP address that's being identified as the source. The destination IP is 172.16.1.10/32. And as you recall, that's the IP address, the additional IP address that we assigned to this S615 on the left. And then the translated destination IP subnet will be 192.168.1.10/32, which is going to be this device on the left, this PLC CPU, and that device alone. So any traffic that comes in from this device and the destination is identified as this IP address, that address is going to be translated and the traffic will be directed to this device on the internal side at 192.168.1.10/32. The same thing, same thing applies for our second mapping that we do for traffic from the PC to the second CPU. A firewall will be established when we create these two mappings, and it will say that we will accept any traffic from VLAN 2 to VLAN 1 going from this range, and this range with the /32 is not really a range, it's this device alone, and the destination happens to be all the way down here on our internal side, that device alone. And in this particular case, we're not doing any port masking or anything, or any port, we're not prohibiting any ports from being part of this service. So that's basically what we're going to do. Like I said, a firewall will be created. We'll just touch briefly on firewalls. Of course, the security benefits are that it blocks unwanted traffic. It allows you to monitor the traffic that does take place. And it allows policy enforcement where you can restrict certain IPs and restrict certain ports from being communicated. It also hides certain network vulnerabilities. If you have unpatched PCs, it's somewhat protected behind the firewall. Okay, most of the firewalls that we use are going to be stateful. If you use a stateless firewall, a connection has to be established for every communication that comes across. So it's kind of it's not a very efficient type of firewall. If you do a stateful firewall, you can track the operating state and characteristics. The firewall is remembered by the device, and then since it remembers the connection, it's more efficient and it's able to delineate legitimate messages from for different connection types. Okay, so at this point, let's go ahead and get into some of the lab exercises, and I want to turn it over to Tom DeFreitas in our Orlando office for that first lab exercise. Tom?
Thanks, Keith. And let me share my screen. Okay, you should be able to see
Hear and see you, Tom.
Great. So here is another illustration of what Keith just described and what we're actually going to demonstrate today. I've got two stations, Station 1 and Station 2 on the right, that are essentially the same project that was built with TIA Portal using an S71200 and the comfort panel, a TP700. This is a simple automation application where we have a PLC and an HMI talking to each other. They happen to be on the same subnet, 192.168.1.10 for the PLC. And the HMI is assigned 192.168.1.11. Now, in a typical scenario, these may just be connected directly to a plant switch, but in this case, we have a plant network that actually is on a different subnet, and we want to be able to connect this automation system to the plant network and protect it without having to change the IP addresses of the existing automation system. So in order to do that, we're using the S615, and I'm going to go through the steps in configuring the external and the internal interface for the S615. And here we have an engineering PC, which is going to be my laptop that I'm currently presenting on it. I've actually assigned a network address as 172.16.10.100 to my engineering PC so that I can access devices. And we're going to restrict access to the automation systems to specifically that PC. As Keith indicated, that subnet mask, when we put in the destination NATing rules, if we put a /32, it locks it down specifically to that IP address. Now, certainly we could open up that subnet mask to allow a range of IPs to access. But for this example, we're going to lock it down specifically to that PC's IP address. So this is the illustration of the network. And let me show the actual stations that I have here. Now, the S615s that I have these stations connected to are currently defaulted, and my automation system is simply connected right here. I have my PLC is connected in port 3 of the S615, and my HMI is connected in port 4. Now, the internal IP address or the internal default interface for the S615 is on the 192.168.1.1 network. And that's why you can see my automation system is currently functioning. My PLC is communicating with my HMI is communicating with my PLC on both sides. I'm going to get into the web-based manager.
Hey, Tom, we're not seeing your camera view.
Oh, I'm sorry. I must have shared my wrong screen. Let me share the screen. Sorry, I apologize. I shared my display, not the screen.
We can see it now.
So here we have station 1 on the left and station 2 on the right. The PLC for station 1 is plugged into port 3 on the S615 here, and the HMI for station 1 is plugged into port 4. The numbering of these ports actually is port 5, which is the external port, is on the top, and then port 1 through 4 are below. That's the way the ports are actually physically numbered. But the S615 in this state on both stations is currently in a default state. And like I indicated earlier, the internal IP address for that interface on the internal side of that S615 by default is 192.168.1.1 just out of the box. And that's why my PLC is able to communicate currently with the HMI. But we're going to, and I just happen to assign my automation devices to that network. But we're going to go ahead and assign some security here and assign that destination address translation as well as the masquerading. When you first log into the web-based manager, I don't know if I can minimize these controls. When you first log in, you have to change the password for security reasons. So I'll do so here. And when we change device, most of the screens that we change, if we edit any fields, there is going to be a set values button at the bottom of the display in order to write those values to the PROM of the S615. When you first log in, the S615 puts you through a wizard. And the first screen here, it goes to the IP addresses. And here is that internal default IP address 192.168.1.1 that I indicated that VLAN 1 is on. So VLAN 1 is for ports 1, 2, 3, and 4 on the internal side of the S615. On the external side, it's defined as a VLAN 2, and that's port 5. Now I'm going to uncheck DHCP here, and I'm going to put this external port on my plant network. and I've defined my plant network as 172.16 1.1. So my plant network is actually at 172.16, and it's a class B subnet. So my subnet mask here, as Keith indicated, for a class B network would be 255.255.0.0. I click next. Here I can actually assign a station ID. This will be my station 1. Little typo. I can set a location, and I could set up a contact. Next, I can set this up to use or synchronize with my PC time, or I can actually set it up to read time from an NTP server. I don't have an NTP server today, so I'm going to just synchronize it with my local time on my PC. I click next. We could set up a dynamic DNS addressing here for a host. I'm not going to do that in this example, so I'm going to click next. Later on, we will actually show remote connection through our SINEMA RC server, which will provide us VPN access remotely, off-site remote access directly in here, where we will assign a server, a SINEMA RC server IP address, use a verification fingerprint and a device ID to ultimately have these components, or this S615, connect to that SINEMA Remote Connect server that happens to reside in Jacksonville. But for now, in this example, I'm going to leave this off, and we'll enable that later during the SINEMA RC demonstration. So I click next here, and it gives you a summary. The most important part here is my internal VLAN IP address and my external IP address for VLAN 2. And I'm down the bottom, I'm going to click set values. And when I do that, it writes those values to the PROM. I have the ability on the S615 to put it in trial mode. And in the trial mode, what it allows me to do is make changes to the port configurations. And if I happen to lock myself out by creating either a firewall rule that prevents me to gain access, I can simply cycle power on the S615, and it will restore the values that haven't been written to the PROM yet. So it's a nice programming tool here. So while you're configuring the device, you can just kind of do it in a trial mode. When you're done working on it, you can set this back to the automatic save mode. So I have my external port set up. If I go into my layer 2 tab and look at the VLAN setup, we can see the 5 ports on the S615. Ports 1 through 4 are associated with VLAN 1, and port 5 is associated with VLAN 2. If I look at my subnets under layer 3, we can see here VLAN 1 has an interface address of 192.168.1.1, and that's how I am accessing the web-based manager here. My programming unit is actually plugged into port 2 of the S615, and that's why I'm using this address to get to this interface on the web-based manager. But this essentially shows the interface addresses for these particular ports and VLANs. Just below the subnets is my network address translation. Here is where I'm going to enable masquerading. I'm going to set values, and I'm going to jump over to my NETMAP rules, where I'm going to set up what they call destination network address translation. And this is going to translate any any packet data that is targeted to my external interface for my PLC and HMI, I'm going to translate that plant IP address to the internal side IP address on VLAN 1. So I'm going to set this type to destination, and my source of data is going to be from VLAN 2, which is my external port, to VLAN 1. Now, for each device that you wish to reach on the internal side of the S615, you need an IP address on the plant network for that. So I have 2 devices, so I'm going to use 2 additional IP addresses on the plant network. And for simplicity, I've identified 172.16, 1.10, oh, excuse me, this is my source address. I apologize. All of the data, I'm going to lock it down from a source IP address that is my engineering PC. I'm only going to put a rule in here that says the PC that is trying to reach the PLC and HMI has to have this IP address. So my IP address is 172.16.10.100, and that /32 locks it down to that IP address. The destination IP, here's where I put in the additional IP address for my PLC. My PLC, the additional address I'm going to use is 172.16.1.10. And again, I'm locking it down to specifically that PLC with a /32. And that's going to get translated to my actual internal IP address of my PLC, which is 192.168.1.10. And here there's a checkbox below that I can activate based on this destination natting. I can create a firewall rule as well. And I'm going to click create. So this is what the rule looks like. Destination from VLAN 2 to VLAN 1, which is my internal. From this source IP address, anything that queries on the plant network 1.10 will get translated to 1.10, which is my actual PLC. That gets me to the PLC. If I wanted to get to the HMI, I use an additional IP address on the plant network, and in this case, I'm using a 1.11 host address. That's going to get translated to my IP address of my HMI, which is set to on the internal network of 1.11. I'm going to also create a firewall rule for this and select create. So now the top line is a destination NAT rule for access to my PLC 1. And the second line is a destination NAT rule for my HMI 1 or station 1. If I look at the firewall, that checkbox came over here and created, this is what it inserted for my firewall rules. Again, source IP address, specifically my engineering PC, down to the destination of my HMI .11 and my PLC 1.10. If I come over here to the predefined rules of my VLANs, you can see that the firewall rules for my VLAN 1, which is the internal side, allows these services to get through. But from the external side, it doesn't allow any of these services. By default, it has IPsec, VPN, and DHCP enabled, but I could uncheck those as well. My firewall is enabled. So in order to verify this, let me click back over to my camera. So my settings are set now, and I'm connected to port 2. If I take my laptop out of port 2 on the internal side of the network, and I'm going to plug in to this switch. And just to illustrate how this is connected, this port 5 here is connected to the plant switch. If we want to call this switch here the plant network switch, that's my external network. So I just took my engineering PC that I was configuring the internal configuration of the S615, and I moved it from the internal side of the S615 to the external side, okay? And I have a firewall active. So if I were to open up a command prompt here, I cannot ping from the external side 172.16.1.1. So I'm not allowed to ping. What this ping is actually trying to do is from my external side, it's trying to ping this port on the S615. So since my firewall is active and it has disabled the ping functionality, we can't see that. And in addition to that, I can't ping even the plant side. Actually, 1.10. Oh, I can do that. I have masquerading involved. That did. Well, I'll get back to that. So now what I want to demonstrate is we have access through TIA portal. I have my program open here. I can open up the main OB for my program. I can go into extended online. And when I do that and access it from the external side of the network, I put in the address of 172.16.1.10 as opposed to the actual IP address of the device at 192.168.1.10. Now it has found it at 172.16.1.10, and I can go online with the device. If I were to try to get online with its, here I can monitor this network. Oh, excuse me. So I just have a simple start-stop circuit here where if I were to pull up this screen, if I were to start my motor on network 1, you can see it latches in the circuit here. I could actually press stop on my HMI and it stops it on the HMI. I have the feature called Smart Client activated. One thing I should illustrate here is if I wanted to actually try to go online, if I wanted to try to go online specifically with the 192.168.1.10 address, it's attempting to connect. So not only would somebody need to know, so if somebody had the project and were able to access the project from the external side of the network, the devices won't be found. They have to know what address that's being translated to at the 1.10. To show access to the HMI, I use Smart Services here, which I've activated on the panel. And the IP address of the plant IP address of the HMI is at 172.16.1.11. If I press connect, I log into the HMI, and now I have smart service access for that HMI. If I click over, here's my camera view, and here's my smart access. I can start and stop the motor on station 1 here. If I start station 1's motor from the HMI, and there's a timeout. If you're familiar with smart services, there's about a 15-second timeout. You can see where my mouse says no input here. Until that time's out, I won't have control over here, but I can actually turn off the motor. So now I've configured station 1 on the plant network. And going back to the illustration here, what if I happen to have another system that I wanted to connect to my SCADA system that an OEM or an integrator has provided? It's a standalone system that hasn't been integrated yet, and it happens to have the same IP scheme as another device within my network. I can put that device behind another S615 and provide the same NATing rules. So what I'm going to do right now is I'm going to switch over to my second station. So I'm going to take my engineering PC and I'm going to plug it into station 2. And with station 2, I've defaulted it as well. And it's going to have a similar setup. I'm going to log in here with my default password. It asked me to change my password. And I'll go step through the wizard. On this device, again, the default internal network is 192.168.1.1. I can freely change that to any network I wish, but for this example, we'll leave it there. The external IP address on this device, I'm going to assign to 2.1 for station 2. And again, this is a class B subnet, so this third octet will be a 0. I'll click these values and click next. I'll assign a name, station 2. This is also located in Orlando. We'll put in a contact. Once again, I'll use my PC time. I'm not using dynamic DNS. We will set up SINEMA RC for the next example. And I'm going to set these values. So for station 2, I'll jump right into the layer 3 NATing rules. I'll enable Masquerading, set values, and we'll go to the NETMAP rules. Once again, destination from my external network. Waiting for this to catch up. And this is going to be from, again, my field PG. Now, station 2, I'm going to use 2.10 for the PLC address. This is an additional IP address that I'm using on the plant network for the PLC, and its internal address is the same as my station 1 IP address. And again, I'll set up a firewall rule there. So from my PG to 2.10 is going to get translated to 1.10 in this S615. And to access its HMI, I'm going to, my additional IP address for the HMI on the plant network is 2.11, and the internal is the same as station 1. And I'm going to set a firewall rule up for that. So now I have my rules, my firewall is set up. These are the firewall rules, similar to station 1. And I can open up my TIA portal project. This is the same project that I just had open. And if I go to extend it online, because it's the same project, I can say extend it online. And instead of going to the IP address of station 1, I'm going to put a 2 in here. And it'll search for station 2's PLC. Oh, I didn't move my port. I need to move my cable to the external side of the network. Got a little ahead of myself. So I just moved this cable here from the internal side of my station 2 S615 to the external side. So let me make sure that this is going to connect to station 2. Once you set up these rules, you need to come from the external side. So it has found station 2. I can go online. So once again, this is the same project that I'm using for 2 different systems. So if I'm online here, I can pull up my camera view and push it to the side. And when I start the motor on station 2, you can see that the circuit latches in my TIA portal behind. If I, just to show that I'm not doing anything, if I start station 1's motor, you can see that the circuit isn't latched. Once again, I can open up smart services to access now the HMI on station 2 by putting in 211, putting in my smart service password, and now I have access to station 2's smart service. So I can, if I start station 2, you can see portal latches the circuit behind here, and then on my camera you can see that it stopped that pump or motor. So just to follow up, if I were to change the IP address of my laptop, if I come in here in the properties, as I indicated, my engineering PC, I've provided privileges strictly to 10.100. So just to show that it's locked down to that IP address, if I change this to 101, you can see immediately my smart client disconnected and my station went online and I'm not able to reach it. So if I wanted to reinitialize my smart client and get to 2.11, it's trying to connect, but it's unable to connect. If I come back to my field PG and go into the properties again and put this back to an IP address of 100. And open up Smart Services once again. I can get into Station 2. That's Station 2. And let's see here. Smart Client. And if I open up another one, that's Station 1. And if I can overlay my camera, we can see that I have access. I can actually start Station 1's motor, and I can access and stop, turn on Station 2. So that is, I'm finished with my demonstration. I'm going to throw it back to Thomas, and we're going to do a demonstration of SINEMA Remote Connect to show how to access these devices from a remote site. Thank you.
Thank you, Tom. Powerful stuff. Can everybody see my screen?
Yes.
All right. So let's just do a summary of what we've done so far. We have 2 machines that are now securely connected to our company network. We've maintained a local IP address structure at each machine without conflict. We also, Tom showed us that we kept the same project for each machine, which can help with consistency. And we were able to, also restrict access to who we want to access those machines. And how did we do it? Well, we installed that security device. The security device is the S615. We set up Masquerading. We set up network address translation or NATing. And we set up the firewall rules. So, Tom, thank you very much for taking us this far. As you can see with the internal and the external IP addresses here in the different stations, but let's do some more. So what's next? We want to create another plant site. Let's call the existing one Orlando. So we'll call, what we have here at this company network Orlando, and let's create a new one. And we're going to call that one Jacksonville. We want to add in another machine, just like the others. And we want to be able to set it up and to communicate with that on the company network there. So not only do we want to do that, we also want to be able to securely access any of the machines, no matter which company network we're on, and we want to be able to access it from anywhere. So let's see, we also, from that, we want the capability to manage that access of creating users, different access levels, different capabilities, to be able to delete users on command. And we want total control of the process. So we want to be able to host it. We want to control it. We don't want to have any of our information on a third-party server, or the connection done by a third party, or it might end up on a foreign server, anything like that. We want to own the process. So how do we do that? We're going to install SINEMA Remote Connect, which is a software package from Siemens. We're going to call it SRC for short, on a server that we host that has a public IP address. We're going to use the management capabilities of SRC to create different groups of machines. From there, we can create different roles that have specific rights and capabilities, and that also has access to specific groups. And then we'll set up users that will have those specific roles. And then we'll assign the different security devices to those groups as well. So just to give you, as we're talking about SRC, here's a quick demonstration or description of groups, roles, and users. So when we're talking about groups, we can make groups, and then we can make groups of groups. So let's say that we wanted to make a group for each of the machines. So I'm going to have the machine 1 group, the machine 2 group, and the machine 3 group. So I can make a group for each one of the machines. I can make a group for a site like Orlando. So Orlando is going to contain machine 1 and machine 2. Likewise, I can make another group for just Jacksonville that has just the Jacksonville machine there. And then I can create even another group of all the machines, or an admin group, something like that, where you've got everything. So again, I don't have to add each one of the particular devices. I can just say, I want this group to be comprised of the Orlando site and the Jacksonville site. So that's kind of how groups work. So that when you see Bob go through the steps on actually creating that, you're familiar with the process. Now let's talk about roles. We'll think of the role as an engineer. So we want them to have specific rights. What can they do? They need to have change rights to be able to alter things, and we can assign that role, those specific rights, and then the group that they're able to make those changes on. So we can assign them the all machines group. Well, we can also create another role. Let's say that it's the Orlando maintenance team, that they don't have change rights, they just have view rights. So they can just view what's going on. And for the site, we'll just have them be Orlando, and they wouldn't have access to the Jacksonville machines. So that's it for roles. And then when we create an individual user, so someone that actually does the login and uses the client to log in to the server to get access, for that particular user, then we assign the role. So user 1, we can assign the role of engineer. So that's just a quick description to make sure everybody's on the same page, to help you follow along. And with that, I will turn it over to you, Bob.
Thank you, Thomas. Let me go ahead and share my screen here. Okay.
We see your blank screen.
Okay. Give me 1 second. All right. Can everybody see my screen?
Yes.
Okay, so we're going to look a little bit at enabling remote access with the SRC, the SINEMA Remote Connect, and we're kind of looking at an International Space Station view here. We have all our different machines throughout the world, and we've got a server sitting out there, and we've got our client. It could be anywhere in the world, okay? And he can access any of these machines and the SINEMA remote server via VPN connection, okay? So SINEMA RC is a server application, and with SRC, users can maintain widely distributed plants or machines with remote access and conveniently and securely, okay? SRC provides a secure connection to the machine so it can be maintained. For example, by using TIA portal, we can get in, we can make changes to our program, we can download, we can monitor, we can see what's going on. We create tunnel connections between the plants, direct access to the company network into which the machine is maintain. So, you know, we're going to use the company network to get to our machine. Okay. We'll have a device list function, and we'll look at that here in just a sec with a SINEMA RC client. And we have simple assignment of rights, you know, that Thomas talked about. It's a very user-friendly web interface. And there's an auto configuration of the Siemens routers for the SINEMA RC client. So some of the SRC functions: the management of devices, configuration of rights and groups, connection management. It's an encrypted open VPN connections. We have the M800s devices are our mobile devices, which have a wake up SMS. So we can send a wake up text to it, so we're not chewing up our data plan constantly. Or we can use a digital input. We can do the same with the S615. We can use a digital input. Maybe that end user doesn't want us to be getting access to their machine 24/7, and they can select when they would like us to access their machine by putting in a digital input into the S615. Support during configuration is the auto configuration for the devices and users is supported in the Scalence M800s and the 615s and the RC client. Connections and subnets behind the Scalence MRS, the support of routing. We can do firmware updates, the one-to-one NATing for local identical subnets, like Tom had showed with the behind the 615, we had the 192.168 network, and it was the same on machine 1 and machine 2, and net mapping for dedicated local IPs. So some of the SRC internet accessibility is the basic settings on the server. So SINEMA RC can be reached via the internet. We can do either static or fixed IP. Dynamic IP addresses are ones that change from time to time. So you would need something like a DYN DNS host, or the FQDN, which is the fully qualified domain name. There's some port forwarding rules that need to be opened in the router, such as the secured HTTPS or port 44.3, TCP port 5443, and a UDP port 1194 for the open VPN IP address of the internal gateway. So here's a little sequence of connection, how it's established. It's in 3 steps. Step 1, the Scalence device, whether it's the M800 or the S615, does the basic parameter assignment, the server IP address and port, and the type of authentication. The HTTPS connection is established, and the authentication with a fingerprint or certificate. The server then authenticates or denies the device. Step 2, the start of the auto configuration. The server sends some networking settings and open VPN config file. The device downloads the open VPN configuration. And then step 3, the device starts the open VPN, establishes the open VPN tunnel, and the server starts the application. So that's about how it works between the SINEMA remote server and the devices that are out in the field. And with that, we're going to go ahead and get started with our lab. So I'm going to close this down, and I'm going to bring up our SINEMA Remote Connect.
So you're accessing the server right now, Bob?
Yes, I'm accessing the server right now. Okay, so here's Tom's two stations out there. Currently they're offline. Okay. So what we're going to do first is we're going to go to our participant groups and we're going to go ahead and set up our groups. Okay, so in order to do that, we need to hit create. And we're just going to give this one a name, machine 3. Machine underscore 3. Okay. And we'll go ahead and press save there. All right. And then we're going to create another group. And we'll call this one Site Jacksonville. And we're going to make him to where members communicate with each other. Okay. We'll go ahead and press save there. We're going to go over here to the communication relations. And we're going to click on the site Jacksonville and do the edit group. Okay, and so right here we want to make sure that we can get to machine 3. And then I'm going to uncheck site Jacksonville from here. And I'm going to go ahead and press save. Okay, and then I'm going to go ahead and exit this dialog. And we'll see that Jacksonville has machine 3, Orlando set up for 1 and 2, like Thomas had showed us in his diagram. We're going to go ahead and create some roles now. So we'll go over here to user accounts, roles, and we're going to do create. And we're going to name this one engineering. And in the engineering group, I'm going to go ahead and select all these. But I'm not going to select manager and user roles. We're going to leave that for the admin. Okay, and we'll press next. Now here is where I'm going to give the engineers authorization to site or Jacksonville and site Orlando. And we're going to press next. Here's where I could be, you know, if I had some temporary users or something, I could give them, you know, 30-day password or anything like that, and how many times they can reuse the password. We're just going to go ahead and press next here. There's also a PKI policy where you can disable temporary users here in 24 hours. Press next there. And then this UMC policy. So what we're going to go ahead and do now is press finish. And we're back to our roles. We're going to add one more role here, and we're going to call this one maintenance. And it is in my drop down because I've been practicing. So you'll see it in there. And in our maintenance group, I'm going to go ahead and let him do create backups and, you know, restore line system. Okay. And it's pretty much the same thing here. You know, we'll give him access to Jacksonville and site Orlando, a password, PKI, UMC, and then we'll just press finish. And so now we've got our two roles set up, okay, for maintenance, and we can see everything that maintenance has. And then we can look here at engineering and see everything that engineering has other than the manage the roles. So now we're going to create a user. And we'll go over here, create user. And we're just going to, for simplicity, we're just going to call him user 1. Okay. His login method is going to be password. And then his rights, we're going to go ahead and add engineering. Okay, and we have to press add. So you see all those ones that I had created since I created the engineering role, so it automatically filled all this stuff in for me. So once you do the role one time, and then you add, you know, multiple users, it makes it a lot faster to configure all this. We'll press next. So his rights are automatically set for Site Jacksonville and Site Orlando. Press next there. We're going to be using the Open VPN. Okay, so we'll go ahead and press next there. And we're going to give them a password. Okay, and then after we give them the password, we go ahead and click finish. So now we have user 1 in here with our admin. So right now we're going to go ahead and set up our device. So we have we're going to go ahead and create a new device. So we'll just press create. We're going to call this one Station 3. And we're going to give it a password. Okay, here's our type of security device. So here's our 615, which it defaults to, but if we had any of the mobiles, they would be right here. And like Tom had mentioned earlier, that we had the 1243-1s that go right on to the 1200. Same way with the 1243-7, the mobile, the cellular one that goes right on the 1200. Now, keep this in mind, if we use any of these two here, we can only get to the PLC. The 1200 won't allow any routing behind it. So we wouldn't be able, if we use this, we wouldn't be able to get behind our PLC to our HMI or anything else behind it. That's why we have the 615 in here. Then we can get to all our devices that are behind that router. Okay, we're going to say this guy's in Jax. Here's the Open VPN. Okay, our connection type is going to be permanent. Okay, we can do select digital input. And then in our groups here, we're going to go ahead and press add for admin. Okay, and then I'm going to create another one for machine 3. Press add there too. I'm going to go ahead and go next. Now I'm going to create a subnet, and I'll call this one subnet 3. I'll hit add here. Okay, and then for my participant groups, I'm going to add the admin. I'm also going to add machine 3. Okay, and my subnet IP is the 192. This is where I'm going to do the netting. 192.168.1.1. Okay, so that's that 615 to get to it, and then he had the 255.255.255.0 class C. Okay, my NAT mode is going to be 1-to-1, and on mine here I'm using 172.17.3.0. Okay, so mine's .3 because I'm at station 3. Now I've already configured Orlando's as far as their NATing address, and it was 172.17.3.0. 1.0 and 172.17.2.0. So once we get all those in, we can go ahead and click finish. So now we have our station 3 in there. Everybody is still offline. So we're going to go to the information icon, and this is what the information that the S615 needs. Okay, needs the device ID. It needs our server address. It's going to need our fingerprint, our station name, and connection type. You know, which device we're using, the Scalance, of course, the 615, and the Open VPN protocol, the permanent. So with all this done, I'm going to go ahead and copy my fingerprint, and we'll come back to this in just a second. Right now, I'm going to go ahead and open up another browser, and I want to get to my S615 that I have here in Jacksonville. This is that password that I created when I was creating devices. Okay, so it's telling me I'm having to change that. Oh, my first password I forgot. Okay, is the admin, because it makes me change it right away. The default password has to be changed. Okay, because I've defaulted the device. Now this is the password that's going to match with the one I created for the device in SINEMA Remote Connect. Okay. So here's our IP address to the SINEMA, or to the Scalance S615. We have DHCP selected on our external. The DHCP server has already dished out an IP for us. Okay. We're going to go ahead and click next. So here's the device name. So I'm going to put in station 03. The location is Jacksonville. And the system contact is KT. Okay. So after we get all that inputted in, we'll go ahead and click next. This seems to not be going stuck on this screen for some reason. Let me see what's happening here. We'll save that. Am I still on the air? Everybody can hear me okay?
We can hear you.
Okay. Huh. I wonder what's going on with this. I might have to maybe get out of this, and let me see if I can launch another instance. I'll close this one down. So here's that basic wizard that we were just in. I'm not sure what was going on with that. That's the first time that that's happened. Maybe it was because I used that KT as my contact there. Go ahead and fill that in, and we'll just leave that blank. There we go. So here's our time. It was that KT. Okay, so this time we're going to use our PC time. We can use an NTP server, but just for our demonstration purposes, we're going to go ahead and use the PC time. And we'll click next here. Okay. Here's where if we had a dynamic DNS, we would set in whatever that host name was, but we're not using any of that. So we're going to go ahead and click next. Now here's where we got to add that fingerprint. Okay. So I'd copied it to my clipboard. All right. We'll see if he pastes in. Yes, he does. We'll go up and we'll look what our SINEMA RC address is. I believe it's 173.137.210. And our device ID, I think it said it was 24, our type of connection. So this auto would be if we had one of the mobile, the M800s, and we were using that wake up text, the SMS, we would click auto here, but we're gonna have a permanent connection, okay? So we wanna make sure that we change ours to permanent. We gotta put in the password, okay? All right, we got our password, fingerprint. Let's just double check this device ID so we can go back here. Yep, device ID. Okay, there's our fingerprint, station, Siemens, permanent, okay. So we take all that information, we put it into our 615, okay, and then after we get all that in, we're gonna go ahead and enable SINEMA RC, and then we'll press next. Okay, and we get the summary. Okay, shows us all the stuff. Here's our DHCP address. So everything here looks good on the basic wizard. So I can go ahead and go on out of that. So we definitely want to come down here and hit set values. Okay, and then we can go here to this hyperlink, and I'm just going to go ahead and write startup config. Okay, and the configuration has been saved, so we'll go ahead and save it. Now let's go back to, we can go here to information, and we can look at our SINEMA RC. So it tells me that we have an established connection, okay, on our 615 that he has connected up to SINEMA RC. So everything there looks good. So I'm going to go ahead and go back here. We'll exit this dialog here, and we see that everything is online. Now what we'll do is I'm going to go ahead and launch the SINEMA remote client. Well, okay. So here's my SINEMA remote client. This is the software that you install on your PC. Okay, so here's the server address that I want to get to. There's my username, and then I'm going to put in my password that I created for that user. Okay, we'll go ahead and log on, and we can see that everybody here is online. Notice over here, everybody has the same IP address. Okay, on the local side, the internal side, but on the NATed, Okay, we have the 172.17.1 for station 1, 172.17.2 for station 2, and the 117.3 for station 3. Okay. So what I'm going to do is I'm going to go ahead and I'm going to click yes, and I can gain access to all of my devices all at the same time. Okay, so I'm going to go ahead and hit the connect button, and it's going to go ahead and create the tunnel. And once the tunnel's created, you see I got this little home now. And what this home does here is this takes me to that web base manager, the WBM of the 615. Okay, so you know I can get down there to Orlando's web-based manager on his 615 right here. You know, on these two or any ones that I have in the world. But once we create this, this is all we need. So we can go ahead and minimize this guy now. All right, and we're going to go ahead and bring up our TIA portal. And let me just bring that up to the top. So here's my TIA portal project. It's the same exact project that Tom had in his demonstration. Okay, so we have our 1215 here, and we have our HMI, and they're both on the 192.168.1.10 for our PLC and 1.11. Okay. So what we want to do is we're going to go ahead and do our online extended go online. Select the devices. I'm just going to do this one. Okay, so I'm going to change my PGPC interface to my network connection that I'm going out on right now. Okay, and then down here I'm going to put in the NATed address, so station 1. Okay, and I'll hit enter. And I'll let this donut spin for a little bit. So you can see I've made the connection. So I can go ahead and click go online. And we see that I am online. We got all green. Green is good. Okay, so we'll go down here to our OB, and we'll go ahead and turn on our glasses. You can monitor our station 1. I'll go ahead and launch my SINEMA remote or my smart server, and we'll just go ahead and punch in 1.11. I'm sorry, all my stuff comes down on my bottom screen. Put in that super secret password. And then we have the HMI that's sitting in front of Tom's desk right now. Okay, and I'll go ahead and start the motor, and we can see that my logic is working. Go ahead and stop it. You can also go over here and go offline. And we'll go online with the other one. Extended go online. We'll just use him. Go online. I'm going to use my same outbound connection. It's connected to our company network. This time my NATed address will be 2. Press enter. What happened there? Two 17.2. Okay. That guy's right. One 7.2. Oh, 117. No, that's right. Public. Huh. Let's look at this. Go online. Extended go online. Let's go here. Let's try my wireless. No, this wireless. Try that again. 172. So we're attempting to connect. We can look at our client. It says we still have a connection. Do a refresh on that. I'm not really sure what's going on here with this. Let's see if we can get to Jacksonville. Okay, I can get to Jacksonville. I can go online. So here's my Jacksonville, same project, okay. This one here was the one from Orlando. So let me start a new one here. And we'll bring up 3 here, press connect. Okay, and here's my HMI. Go ahead and hit start and stop. Everything's working good there. And let's just see, if I close this guy down here and I bring my smart client back up, I want to see if I can get to this here. Well, it looks like I can get to the HMI. Yeah, I can get to the HMI. So right here, my portal is connected to station 3, okay? But my start stop here is connected to station 2 on my HMI. I'm connected to, my HMI right now is connected to station 2. So that's why we don't see any logic happening here. We'll go back one more time and we'll see if we can't get to that station 2. Go ahead and go offline. Okay, I'll do online, extended go online. I'm gonna go ahead and we'll use that wireless card again. And we'll change him over to 2. Huh.
Bob, someone on the chat line mentioned that perhaps you used a space in the location text.
Here?
No, I think back when you defined the location in Cinema RC.
That was a while ago.
Okay.
Yeah, the space in the Cinema RC, because see, these two stations were already pre-configured. I only did the one.
How about station 1, Bob? Can you connect to that PLC?
Yeah, let me double check that and see. Okay, so let's go ahead and make sure we're offline. Extending online. Let's try this. I don't think there's any extra spaces or anything there. There. Yeah, I can still get to the station 1. Okay.
Well, let's show that and show the HMI for station 1.
Yeah, we did that already. That was the first thing I did. So, but we'll show it. So let's do this. I've got this on station 1, and Tom is down there in front of the demo.
Yep.
Okay, and I'll bring up station 2, because we can get to station 2's HMI. Okay, without any issues. And Tom can work both of these from his location.
Yep, I can start station 1. So station 1, I'm starting right now. It's running. You can see. Now station 1 has stopped. And now I'm going over to station 2. Station 2, I just started. And now I'm gonna stop it. So now station 2 is running. And now I stopped it. And again, I can go back to station 1 and start it and stop it.
So this shows that, you know, those 3 connections that I connected back here and the Cinema Remote Connect, that we can access all 3 of those all at the same time. Okay, without any issues. So with all that, I'd like to turn it back over to Thomas. Are you there, Thomas? Thank you.
Thank you, Bob. Just once again, where we are, Bob set up the Cinema Remote Connect server that had a public IP address. Utilizing that at each of the stations, we put in the fingerprint information to be able to connect to that server. And then he created a client session, created a special user, opened it up in the client section, and then from, again, anywhere in the world, he was then able to access each of these stations. So excellent work. It's a very powerful tool to have security and secure access. You can manage who has access to what, and we appreciate that. Just to let you know a little bit about AWC. AWC is an established company with decades of experience supporting Siemens solutions in the southern United States. We're proud to be an employee-owned company, and we support our customers with a team-centric approach that involves outside account managers that can go to your facility, meet with you. Even today, we are absolutely, as long as you're practicing good social distancing, We are happy to meet with you. We have inside account managers that you can call at any time. And we also have our highly technical application engineers. So we take a team sales approach. If you do need technical support, multiple ways to do that as well. You can get in touch with us through our website. We have web chat available. We have a 1-800 tech support line. And then you can also send it to email as well to our tech support email. And you can always contact us with questions as well. This concludes our workshop on cybersecurity, defense in depth. We hope that it was a productive use of your time. At this time, we're available for any chat questions if you have them. All right. Well, I don't see any right now. Here's one. Well, thank you, Eric. Thank you. If anybody has any questions, we are here. I'm going to go ahead and stop the recording. Again, we will send out this video link as soon as it's available to all those who attended and all those who registered. If you would like to review the recording, thank you very much for your time today.